CPM Math 3, problem 1-104. For each of these, we're given quadratic equations and we are being asked to solve. And a really cool hint right here is that they want us to give both exact and approximate forms. That means it's probably not factorable. And actually looking at problem A, there are no numbers that multiply together to give -3, but add together to give +3. So we know that factoring and using the zero product property, not going to happen. And I'm thinking completing the square, we could totally complete the square, but we do have an odd b value. So that makes it, you'd get some decimals along the way, which is not too bad. But then what a lot of students do right then is they jump to the quadratic formula. So let's go ahead and use the quadratic formula. You do need to memorize this. All right, so x equals -b. -b is the opposite of 3 plus or minus the square root, b squared minus 4 times a is 1, times c, which is -3, all over 2a, 2 times 1, okay? And at this point, it's an order of operations problem, and you do need to be very careful with your negatives and your square roots and all that good stuff. So when we take 3 squared, we get 9, and -4 times 1 times -3 is +12. And continuing to simplify, we end up with x equals -3 plus or minus the square root of 21 over 2. And you can actually leave this. This is considered the exact form, but they are also asking us for the approximate form as well. So we will need to put the square root of 21 in the calculator. And when I do that, I get approximately 4.58. So I'm going to break this into two equations. X equals -3 plus 4.58, all divided by 2, or -3 minus 4.58 all over 2. And please use a calculator. I don't care. So when I put this in the calculator, I get -3 plus 4.58 and then divide that by 2, and you get about approximately 0.79. And in this case, -3 minus 4.58 is -7.58. Divide that by 2, and you get -3.59. For part B, we do need to make sure that this little equation gets in proper standard form. So I'm going to subtract 12 from both sides. So we get 3x squared minus 7x minus 12 equals 0. All right, that helps us solve, and I don't know if it's factorable. Completing the square is not an option. I don't know, let's just stick with that quadratic formula since we've had a little bit of practice with it, and let's start to substitute. And let's get this going. And please note that there is a change down here. It's -3.79 instead of -3.59. That's my typo there. So x equals -b, which is the opposite of -7, which is +7, plus or minus the square root, b squared, -7 squared, minus 4 times a, which is 3, times c, which is -12, all over 2a, 2 times 3. Again, order of operations. All right, we always do what is underneath that square root symbol first, and we have -4 times 3 times -12, which gives us a positive 144. So that simplifies. X equals 7 plus or minus the square root of 193 over 6. All right, again, this is exact form. And what we're going to do now is continue to simplify. I'm going to take the square root of 193, and let's see, square root 193 is about 13.89. So we're going to break this into two equations. X equals 7 plus 13.89 over 6, and x equals 7 minus 13.89 over 6. And we do each of those, and the match here we get x equals about 13.48, and on our second one we get about x equals -1.15. And again, these are approximations. Our exact answer is right here.